the usual. Hey, welcome to Coffee Compiler Club. Here today to talk about compilers and language runtimes and generating code and what the hell Go does for interfaces and some register allocation code gen for some bizarre DSP AI-like chips. And I don't know what else was going on before we started here. Um, we're being recorded, shows up on YouTube. I don't have any set agenda. No simple demos today. So whatever we want to talk about. Do we
Yeah.
want to talk about the
Well, I
what
can,
was done there?
yeah, I can, I'll just briefly recap what we were just saying that I hit a big milestone. The compiler that we've been working on, that I started on sort of in February, and I've been working with Cliff on the last few months, is now running on our hardware and uh, running correctly, which is even better.
Yeah, you're running correctly. Woo! Generating code, register
Yeah,
allocating.
yeah, the whole works. So
Yeah,
Um, yeah, I mean, there's still a few things to figure out, but we added the C++ front end to it like in kind of record time, I think, and
yeah.
that's
So let me
that's
qualify for the audience. It's C++ fronting was machine generated C++ intended to represent kernels of AI, AI computations, but it's very
yeah,
stylistic. So we wrote a C++ parser. No. We wrote a parser for a very stylistic dump that happens to be C++ syntax, some
that's a
tiny
better
subset.
that's a much better explanation. And there's a few things that I discovered that we need to add and stuff. But anyway, it's doing the job.
Yeah, yeah,
So
yeah. We got like 5,000 kernels compiled through the thing.
9,000.
And I'm sorry,
Yeah. 9,000.
9,000. Okay,
Yeah.
yeah, a lot.
And a separate ELF file now being generated for each and every one of them.
Oh, nice. Okay, so I didn't do that. That was you then.
Yeah, yeah, I did that
Yeah,
the other day.
and the
So they can all be sent onto the hardware that way.
can I say RISC-V in a sentence here?
Yeah, yeah,
So there's
yeah,
a
it's RISC-V.
RISC-V side and a DSP side, and they same instruction set but different registers, and they all have to get register allocated together. And the DSP side has 30 odd registers, 32, and they're almost all uniquely different and do different things, and every instruction uses a different subset. So it was kind of a interesting test of the register allocator to
And many
think about
many
running.
instructions produce changes in eight or yeah,
Yeah, bunch of registers.
five, six,
Yes,
seven, eight registers
right. They
all in
take
one
5 to 8.
instruction.
They produce yes, and produce 5 to 8. Yes, kind of a
So
wild job, and the allocator's doing it great. So
yeah, and instructions are taking inputs on both the RISC and the DSP side for those
yes,
instructions.
yeah,
So
they have to be register allocated together because they're taking from
yeah,
both. Yes.
yeah,
And the code that's generated is generated on both because the same instruction stream gets pushed left and right. So
yeah.
I didn't do the front
But
end
it
on
looks
that, but I did the
surprisingly
back
like
end.
simple.
Fun.
It looks surprisingly like simple. Like structurally.
That would
I
be they came from the common root.
Yeah,
Does it
yeah,
have a
exactly.
name?
I just call it M2. It
Does
was
it
the
come?
first one
Yeah.
I built was called I called Magic. Everyone in the company hated that name and they refused to use it. So I didn't so finally I was just like, fine, the new one's M2.
I was at Sun, right? And there was a compiler, and everyone agreed it was a bad throwdown compiler and needed a different one. So I started another compiler, and I just used what I came from grad school as an Opto for optimizer directory, and people didn't really like that, and they're sorting around, and somebody decided they hated the compiler I was writing, so they're going to write a faster, quicker, easier compiler, the client compiler. That would have been C1, and then C2 is Cliff's compiler. I didn't come up with that name, but of course it's Cliff Click, so there's this pun on the name as well as a pun on the compiler being the whatever they in their mind was the second tier citizen. But it turns out that 25 years later, C2 was still winning. And I didn't put the name on it. I didn't put the name JIT out either. I was doing JITting and I had it was a fast runtime compiler. And then somebody else was like, it's JITting. What the fuck was
Mhm.
JIT? Where did that come from? It was not me.
Yeah. Hey, JIT
Right.
now it's everywhere.
And
It's
now
in
it's every, yeah,
manufacturing,
right, right, right.
logistics. You inspired the
I inspired
modern world.
somebody, but I did not come up with the name. Fine. Oh, Cameron, you are silent and laughing. Yes, fine. So the other piece is that your company is Untether, and they're making an AI chip.
Yeah,
That was people might look for Untether and some free
yeah.
publicity.
Untether.ai.
Yeah. Um, okay. So that was fun side of cogen. So Cameron didn't want to hear. It was Cliff having fun doing cogen and having worked. Really bizarre chip setup, and it was all working in kind of record order. I agree with you. That was we slammed that sucker together pretty damn quick.
Yeah. And
Okay, so what else?
so I can a bit more update. So I started on the process of moving to optimize. So all of my people optimizations are written in Clojure, but almost the rest of the compiler at this point is written in Java. Clojure is a JVM language, so they're all Java really. But
I'm assuming the audience will know that, but
yeah,
yeah, fine.
yeah. So um, the so anyway, I'm in the process of switching it over
Ah,
to all be Java because right now Cliff refuses to look at my people rules,
I
and
don't refuse, but it's not. They are, let's say, two orders of magnitude slower than what goes on elsewhere. That's enough for me to
oh,
care.
so uh, by the way, our compiler is currently an order of magnitude faster than our LLVM compiler that
Yes.
ingests the same
Yeah,
kernels,
I imagine if you flip over to peepholes in Java, it'll be two orders of magnitude faster.
probably.
And running
So
code is a big step.
yeah,
So yeah,
yeah.
there's a
So
thing going on there. All right. There will be some, yeah, political infighting going to happen. Not yet, but it'll be coming.
yeah, that's all
Somebody's going
right.
to have to stare hard at that, decide to do something about it. Or not,
Yeah.
maybe not. I don't know.
Oh, well,
I've been
we'll
on
see.
both sides of this equation. There's plenty of
Yeah,
people who can stall indefinitely.
yeah, yeah. No, if I hope everyone will be friendly, and then everything will be friendly. But if not, then everyone has their methods that they have
Yeah,
available
my
to them.
hair is going crazy. There's something. Fine. There you go. So otherwise, I've spent the week on doing ecstasy stuff, rewriting core data structures, doing with types for the third or fourth go round. It's been a slog.
Why?
Why is it a slog?
Why the rewrite?
Because I discover yet again a new thing that I had to support that wasn't able to support with the data structures I had. So there's a typing system. It is the union of all possible ecstasy types and Java types, which includes primitives for Java, which ecstasy does not have a clue about. And then ecstasy has a bunch of features that Java doesn't have, which look nice, but they have no straight up translation to Java. So I have to do things that, like inner classes in Java, they're totally a fiction made up by the Java C compiler. They just throw down an extra up pointer. It's even got a name, this $0 or something like that, $0
Hmm.
this. And then there's a magic shuffling under the hood. Well, I'm doing the same thing with the magic shuffling under the hood, except with about 20 more things that had to get shuffled, and not all of them had a direct translation. So the last week's disaster was the blend of mix-ins and inner classes and derived classes. The combination of all of the above was suddenly something I wasn't handling, and I needed more info. So what is a drive subclass? Drive class is a subclass. Inner classes we just talked about. You have a hidden backwards up pointer because Ecstasy's inner classes are not entirely compatible with Java inner classes. The namespace rules change. Then I had to manually do the same implementation that the Java C does as a Java field. Well, that's fine. And then mixins are a different beast altogether. They come
Hmm.
in two flavors. I would claim they're utterly unrelated, so we shouldn't call them both mixins. The interesting one is a conditional mixin, and a mixin is as if you add a subclass to some other class if one of your generics derives a specific way. And actually, it's okay if I go down this path, Cameron. This is all
Yeah,
Mm.
sure.
what ecstasy does here. Let me see if I can go Google Docs and find the share button and see if I can throw some examples into the docs. And I will throw the worst case scenario example in the docs and then maybe break it up down into pieces, parts, so you don't have to try and figure out what the worst case means all at once. Why? Oh, I see, because I was debugging. So I'm playing whack-a-mole. So what really happens is I play whack-a-mole, which means I was fixing one piece of code and breaking another back and forth. And I have the current worst case scenario turned off in my debug test. So I'm going to turn it back on so you can kind of see what it's doing. And then I'll throw it in the doc here. A few more seconds. We can get a feel for what kind of things. Why did you not do this? Hello, Zoom. Oh, wow. Zoom not being helpful. Wow, here you go. Big old thing. Badly indented um, because the paste did not work as hoped for. Not bad. Let me see if I can color code this thing. That'll help. And we'll work it down. Extensions, code blocks, start. Okay. Oh, I have to log in. I'm logged in. Why? This will allow code blocks to allow. Holy crap. Fine. I don't C++.
There it is. There it is.
Is it good enough? I was going to do Java as a
Sure.
color coding. Does it a little better? No change. Okay,
Good
fine.
enough.
So test case called type variables here. I have an interface. Whoops. Hey, come back. I have an interface. Thinks Java interface. I've called it suggestively iFace for interface, and rep comes from the example I came from. And the interface is a generic, and it has a default function. In Java, you'd call this default. The Java translation would have a default string foo calls. Uh, uh, it just returns a string where this is a string formatter for X. It takes a key generic, calls toString on it. It appends iFace rep. Okay. And then there's a second interface here. Same as above, just the names change. There's an outer class. It's inside a method, but that just name mangles its way out. So it's just a standard old Java class. It just happens to be written inside of a method, but you could ignore that for this interesting case. And it implements the interface. So somewhere down here, I make one of these outer objects. I get generic string and object. It's called string object outer. Then I can call foo on ABC here, and I'll get the bad indent again on the, oops, and I can't use tab because the browser's intercepting it. Where is the foo for outer? Outer picks up his foo implementation as a default from iFace rep. So when I call foo for outer with a string, I get foo iFace rep where X is the string ABC. I also make an outer object with a generic int. Now you can't do that in Java, so it's a boxed int. So think capital I integer. And that makes me able to call foo with a 1, 2, 3, which will get boxed. And then I see I get iFace rep with X is 1, 2, 3, capital I integer is a toString. That's great. So that all's pretty Java-like and takes a very straightforward translation to Java. Then there's an inner class. And the inner class has another foo where they knows a third type generic variable is element extends number, and I'm overriding the iFace guy here. So you can start to see where I'm twisting generics next to each other, one after another after another. Also, I can ask for types as a toString on a type, which means like you can't do that in Java without reflection, and you can't get the type of a guy directly as a string object without some kind of reflection going on.
Mm.
So, see, Aaron just showed up. I'll get him a second here. And so these are all actually implemented in my translation to Java as a concrete object that gets passed around and created. So when I make this class in or out, we'll look at the generated code in a minute. I have to pass in a type for key and type for value because they're available to it right here. That's a ask for the variable called key, which is a type variable. And when I make this inner out with an inner factory, so here's my inner factory, makes me an inner out. I'm using int as the element extends number. And then I get an int and I can call it and I can see that x was 1, 2, 3 from this inner x equals. Key is still string because I didn't override key in this set. So I got string from, where the hell did I get key from string? Damn. I don't remember where I got it from, but this is what the interpreter gets as well, Cameron. Where does string come from? And iface element extends number, goes to iface collection extends element, which means element iface is this element, which this element is this element is number, and number was actually an int. So iface element is int. Key iface comes from outer key. Oh, that's because I called string here. I
Right.
did. String object inner factory means that I got new outer with the generic string. That meant key was string and iface rep is string. And iface rep is also key iface. So that's why these are all strings down here. Then I got a derived factory. Here's my derived. So if I ignore the extends, which I'll cover in a minute, he would say, I just have an inner out. Its element typed as a number. It would be derived as a number. This element would be typed as a number. And I would get um, whatever comes from key here, which would be inner out is element extends number, extends whatever. And that turns out to be this commented outline, key int, because I got my int here from the inner factory that I derived from. Yes, I derived from some generic, where to go? IO, inner factory guy, int object dude. Then there's the mixin. And this says I have an incorporates conditional, something called a mixin, which means if my key is an int instead of a string, instead of a number, instead of a double, my key is an int, then use this, not this foo, this foo. Oh, here's your bad indent again. Because this is the mixin, and if the mixin says key extends int. Now, here key was string in some of these cases, but I could make an int version of string. And if I did an int version of outer, which I have an int version of outer, then I would get an int version of derived, and then the mixin would kick in. Whereas if key was string, it would not kick in, but if it's an int, it does. And so you get a mix here, if your key, which is this one from outer here, is an int, and not if it's a string. So that's sort of the worst case scenario of how these things interact sort of gruesomely.
Hmm.
And I didn't quite get the code generated right. And so, and then it turned out I couldn't because I didn't have the right information.
My first question would be element is in because the inner out exports that symbol.
Yeah.
Mm,
Yeah.
mm,
Yeah. As soon as you have a
okay.
type variable and a class in your hierarchy, it's visible all the way up and down the hierarchy. So derived can see elem because inner out has an elem.
Mm.
Yeah, so child classes pick up the type parameters from their parents
Yeah.
automatically. They're not on the child, they're on the parent, but they're part of the overall graph. If you
They're visible, right?
Mm.
Yeah.
So derived here, looking upwards, he has no type variables he makes himself, but he goes to inner out. Inner out says I have an element, and I implement some interface. And I'm coming from outer class called outer. So inner out sees element. Inner out goes to outer, sees key, and sees value. Inner out also implements iFace, which means he has element iFace. Outer implements iFace, so I pick up key iFace. So that's key iFace, element iFace, whoops, key, value, and element. There are 5 type variables available to inner out and to derived.
Yep.
And they get shuffled around in here in all kind of bizarre ways. And in fact, this test case was very closely derived from a test case that shows up in the libxdk. So it is being used this way as well as being written. I mean, just stuff's
Code
going
doesn't
on.
look the same, but yeah.
Yeah. I shortened names and I did a little shuffle to kind of, oh, if this you can do this, you should be able to do that. And sure enough, it broke left or it broke right or it broke up or it broke down. And so I played whack-a-mole and I would get one thing right, another thing wrong, and went round and round and realized I just didn't have all the information I needed. And then therefore I had to go rewrite to go get that information. And kind of a gruesome thing to match
So
through.
that condition is only valid if the mixing is int. If the
Yes. So this line here, this incorporates conditional, doesn't apply if key is something else. But if key extends int, then it does apply. The mixins defined here, or you could define them in other files typically. I defined it here so my test case didn't spread all over the place. Wherever you defined it, it then picks it up and says, if this mixin happens, do this, else do that. And that puts in a dynamic runtime test where I ask the type of key.
hold on.
Key
The
is
mixing
event, do this,
the
else do that.
the mixing method is valid. Am I understanding this correctly? The mixing is valid if the conditional mixing extends. You can call the derived dot mixing only
If I make a derived object and I call foo on it, you check the type of key.
yes,
And you either do this or you do this according to what the type of key is. And it's the whole class, so you can mix in lots and lots of behaviors.
Yeah.
And the behaviors can add new functions and they can override old functions.
So in this case, the foo overrides only if this matches. Okay.
Yeah.
I'll paste an example in beneath this that
Let me see if I have. Am I alive enough to generate reasonable looking code here? I'm back and forth on getting this alive. I have a pretty reasonable code here. Let me throw down some code people can see kind of what happens in the generated code. I'm going to shortcut some things here. So you don't care about this one. I'm going to throw this one down because it just shows you what happens to type vars. This is all auto-generated. It needs to be shrunk to fit because it has these long ass strings, but this is one-to-one with the code that's above. So here is type variable outer takes an ecstasy string, and this is object for ecstasy, XTC. Let me see if I can Javaize it and shrink so it fits on a screen reasonably.
What'd you get that code blocks thing in there?
I see your code blocks, and it does not. You've got a color problem going on.
Yeah, let me do
So I'm name mangling string because it's an ecstasy string, not a Java string. So that makes this stuff. Actually, I can let me redo this in Emacs so it doesn't take forever.
So the code I pasted in shows, that's from the array type in ecstasy. It gives some indication of where we use things like conditional mix-ins. So, the array actually has different capabilities depending on what's in it.
Um, yeah. The other big one, and I'm almost done with my little shuffle here. Shorten the names.
Wouldn't that turn into a very expensive search of what types are allowed or implemented for a particular type for a particular class?
No,
No, okay.
Um, uh,
no. The challenging part is actually the mapping it to Java because there's no such concept. So
I'm going to claim the challenging part is mapping it to any implementation on hardware because there's no such
right.
concept. And the fact that I've chosen Java is sort of a red herring. The same problem would arise if I was trying to implement it in Python or C or C++ or assembly, right? This is the same problem exists.
Why this concept need to survive to runtime? Couldn't it be dealt at compile time and disappears, as if the class array
Well,
has only
that's what Cliff
implemented?
is trying to do.
Yeah,
Hmm.
exactly what I'm doing. Yep. So I wrote code out here that is a one-for-one transliteration of the above outer string, new outer. I have type variable dollar, so it's a name mangle, but then it's outer construct, that's new, string and object, when I'm passing in reified instances of string and object for a type variable. So string.gold is just an empty string object, but it's the special Sentinel one I use to say this is a type variable. Same for making an outer who's constructed with an int and an object. Calling foo with a string, calling foo with a box. Here's the boxing of integer 1, 2, 3. Asserting, that's an ugly assert, but ignoring the ugliness, it's just asserting this and that. Calling inner factor. So I'm getting a one-to-one translation mostly. And a one-to-one translation means that when Java C turns it into bytecodes, it's pretty much one-to-one. And then when C2 hits it, it does the obvious thing and removes all the grief at runtime, other than the size inflation for holding on to these type objects. So you get interestingly good performance, but the translation is non-trivial. So this is just a straight line code of calling a bunch of things. But let's take a look here. What do we got here? For what like the outer class starts to look like. If I can do that without getting crazy, and I'm going to go to here and stop, and we'll see how bad it looks in the guy. It's not terrible looking. Format to Java. Okay, so auto-generated. So I start out with a, hey, I'm dumping a comment that tells me I'm pulling up a TCK class test for X, and it's been name mangled to type vars $outer. And it's a public static class. It's a Java class. There's a type variable key, oops, $key, so I don't have name mangles with not the type. And it's name mangled, so it's not, but it's key and value are type variables. That thing extends object. It has to extend XDC because I need to put a layer in from the Java guy. And he implements an interface. Well, that means that iFaceRep is a Java interface as well. So not shown here, but iFaceRep is a standard Java interface. Everybody gets a gold instance. That's your reified version of the type variable. The constructor using a never is never made, and there's no instances of never. It just gives me a no arg, no work constructor that no one can call accidentally, because you're always in ecstasy supposed to call the real constructor, which does some real work all the time. So a real constructor here, it's the new Java constructor, uh, grabs the type variables. So they got passed in some instance of key and value as types, grabs the type variables and jams them down. So here is a type variable as a local instance and a getter for it. Here's value with a getter. Because outer can see key iFace, there's a getter for it. It's mapped key iFace to key, so the getter for key iFace just gets me key. Then there's the ecstasy demanded constructors which calls new with key and value, and then it calls the ecstasy constructor with arguments. There are no arguments in the constructor proper, so this is empty. And then there's a check, which we don't need to go to here. So that's the sort of header of outer, which just captures key and value and still looks like a Java object mapped directly. Nested inside header is inner out. So this is should be a nested inner class. It's just a static inner class because I can't get the direct translation. And he has an element extends number, and he's got an implements of iFace column collection of element, and object was leftover junk bits, and I wasn't going to dump more, but I certainly can. Buried down inside the derived class will be an instance of test. And I'll show you a little bit of that. You can see there's a runtime instance of test in the derived object somewhere down below. Nope, it didn't cut and paste. Hang on. How about now? No. Why are you? Oh, the window grab is being bad because my Emacs window is right on top. There it goes. Okay, so wow, it didn't bother to do any color coding. Yeah, a little better. Here's derived. Oh, well, wait, it's derived $cond mixin. What happened? Well, I insert a class that I make up. I make a conditional mixin, which is the class that is the combination of the mixin and derived. Now, that same mixin, in general, mixins can be mixed into classes from all over the place. So the mixin's in some other file, and it's mixed into 5 different other classes. In this case, the translation to Java is I extend the derived with a mixin derived, which includes the code for the mixin. So you get a normal derived class as it normally is, and then where the ecstasy guy would think he's talking about derived, he's actually talking about derived $cond mixin in the Java side because I've added on a class that includes the special version of foo for the mixin. And right on here, I have a variable, a Boolean variable that just tests, did you hand me a key that is an instance of N64, capital I integer in Java? And if you did, I'll do an if then or else in code a little further down for foo. In fact, I have that code. And I'll just throw it on here. It's not super pretty, but maybe it doesn't matter. Ta-da, ta-da, ta-da. And here's the foo in condition mixin. What did he do? What? He wiped me out because he got confused. Like, I'm not editing anymore. He's getting confused. The condition mixin foo just tests the Boolean and goes super foo, which gets me to the derived foo. Otherwise, I pick up the X variable, I fix a renaming because when I call the derived guy here, missing is a cast from number to int. This is why this code is currently broken. There are a little extra open close curlies are not necessary. The tabs are hurting this guy, so he can't figure him tabbing out. And otherwise, you would get and this is the second bug, and that's the same bug, and this should dump out the mixin code, and instead it's redumping the derived code. So I currently busted. I know why I busted. That's where I ran out of time last night. Fine. But this is the kind of thing I'm doing. And somewhere in the grand scheme of things, I didn't have what I needed. I think one of the things I needed was I couldn't tell you that the key to test actually came from an outer. So when I go to this key here, it's not available from the Java's point of view as a local instance variable called key that you extend from derived, because derived extends from inner out. Inner out doesn't have key. Inner out has a $outer, which would give him an instance of outer, and outer has a key. So right here, I have to say outer $outer.key, not plain key. To do that, I have to know where the type variable key comes from, which means I have to, starting from the derived class, hunt upwards and find where key came from. And in general, there are several versions or flavors of key. As you saw the renamings going on, I have to get the correct version of key. So I need a history of where type variables came from. I didn't have that history. I do now in the middle of hacking it in. That's what I was doing last week. So
couldn't you export the key at each level to
yeah,
just
so I could
load
make
it?
an instance of key on every inner object as well. So there's several ways to skin this cat. Another way would be that when I go to the inner out constructor, I'm not showing it here, but I could dump it in. When I put the inner out constructor in, it could say, I take 5 type variables instead of, 2. And then I have to, pass in 5 types every time I make an inner out and fill in 5 fields. And the current inner out constructor here, I'll show you this if I can paste it. Oh, yeah, Zoom is being weird on me. He is not bringing the highlighted it's not, Alt Tab is not bringing it up. Let's see here. So here's the rest of the foo, the inner constructor. He has 2 variables he's taking. These are strictly type system. There's no user arguments. Like in the test case, I don't pass any user arguments, but you could totally have people passing in pixels and persons and cats and dogs, and they would show up also. But here, he's just taking an outer variable, an elm, and not key and value and key I face. So yes, I could arrange to pass key in here as well. And I went back and forth and said, oh, I have to solve this. There were several things that were simultaneously sort of left or right shifted. One, this is what I call whack-a-mole, where I can fix this by just treating this information I have as this kind of a thing. And it's very similar to that thing, just slightly different. And then one test case works and one test case fails. And you go back and one test case works and the other one fails. And you push the bug, around and around a circle while you push the meaning of the variables of the data you have slightly about. And then you finally realize that all combinations of all things you have to support are not representable in 2 fields of type data. You need a third field. And then that third field means that everybody is subtly different because they're holding on to different kinds of information. And so everybody who uses them all has to get rethunk what they do. And there are 20 or 30 places I have to touch, and they all get thunked differently, and it takes a while to sort out what they're supposed to have. So that was last week's grind.
Sounds fun.
Sounds fun. Yeah, it'd been fun maybe if I knew all this when I started, but boy, it got all kinds of stuff here. Matt asked a question. Are ambiguous overrides a compile time error? Yes, they are. I'm pretty certain, and it's not ambiguous here. Let's go look as to why it's not ambiguous. So Matt's chat question is, as an outer int. Oh, I see. Were I to add an outer int, and I would pick up foo int from somebody. Yes. Right. So that's a good question. And I can test that one just even right now because I have the whole thing. And I'll just go throw in an int and ask that question. And I'll tell you in a second here. And there it is. Okay, so Matt, the answer is yes. And I need another code block.
Or 3.
Let me make.
Okay, now let me copy the error message again. And, boom. Error, blah, 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 blah. Source main, TCK class medium, blah, blah. Verify class medium type error is outer derived, incorporates with a mix-in of int, but is not compatible with outer int. Oh, I have a different error because my test case. Let me comment out a bunch of things and just see if I can force I need the inner class and I don't need the derived. Here we go. I'm just going to comment that out in my code base and see what happens. So that's interesting. I have to go stare. So the commented out code claims to run. And now what did I actually comment out? I went up here and I said, you're an int. This gives me an int. And then I commented out everything to do with derived because I was having another class that was unrelated. And he says, outer int implements iFaceRep with an int key. iFaceRep means I have a string foo int. There are okay, outer has no confusion because outer only has one foo implemented, the one he picks up by default from iFaceRep.
Mhm.
So now instead, let's look at inner factory, which I didn't test right here. That's a different test. Let me go see what happens. So picking up this guy as an inner factory, he says error. SIO, not SIO.
I
Yes, you can't see Emacs and this at the same time without things. So he's going to claim it's going to run. So why did this work? So I changed this to IO, and I call it inner factory with an int.
So
Outer is int.
what was Matt's question again? It's
His
in the
question
chat.
is it ambiguous? Can you arrange? So which foo gets called? In or
Oh,
out implements, everything's an
so
int.
if you're on in or out, it calls the in or out foo because it doesn't it finds a foo. So even though there are two different interfaces with foo, they're on two different objects. One is on the outer object and one is on the inner out.
Right,
So there's no confusion between those.
right. So it's
Mm,
If
not
you implemented,
ambiguous
yeah,
in
and
this
if you
case.
implemented both interfaces, it would be based on the order of implementation.
Oh, really?
Um, that's right, because you'd have two, if you will, in Java terminology, two default implementations. So which one do you use? And that's based on the order.
Order of the
So the
interface
first
line.
one declared, that default hides the other default. Yep.
I'm saying if I did this, I would get
Which
uh,
the order is which way? The one I call is the one farthest to the right or the farthest to the left
uh,
The first
in
one
the
is
declaration.
registered first. So the second one, its
Whoops.
default slides under that. And so looking from above, you hit the
Oh,
first one. So you'd get the
wasn't
iFace
wasn't
call.
the last incorporated to that overrides that acts as overrides? The last type implemented overrides the other types.
okay, I'm not talking about the mix. I'm talking about just here on in or out.
Yeah,
Mhm.
on that clause where it
Yeah.
lists multiple interfaces, the first one
So
will hide the foo from the first one
hides the foo from the second one.
will make the default implementation of foo on the second one unreachable.
Yeah.
Mhm.
Okay, that's the opposite of how Ruby does it.
I
Oh,
believe
They're
really?
basically mix-ins, right?
And Scala
Yeah,
call
I
it.
didn't. This was a question about this set. There's clearly a morally equivalent question to be asked about what happens on the mix-ins.
Mhm.
Um,
Yeah, so mix-ins are kind of at a different level. So the default methods are kind of go to the bottom of the pile, right? Because because they're only there if you don't do anything or you super to them, right?
so
So
you're
the
saying,
mix-in,
yeah,
yeah,
if the
so the
mix-in
mix-in is
applies,
if the mix-in applies, then it hides the interface one. Yeah.
yeah. Okay, now if I have
Okay.
multiple mix-ins in here,
Mhm.
I take them in order.
Mhm.
Okay. I didn't write that test case, but there's probably a thing to be done there. Yeah, it's kind of it's an obnoxiously difficult problem and obnoxiously simple at the same time. And it's taken me like 3 months to gather the
Hmm.
requirements. And at this point, I'm starting to lock in on there are no more cases to be handled. Roughly speaking, out of here, I get a dozen, 12 unique variations of how I do code gen. And there may be one or two more, but no more than that I haven't yet discovered. And that was, part of the confusion about who generated code for what. And implementation choices, as Theodore was pointing out, I could have moved key down inside of iFace or in or out, and then I wouldn't have to go hunt for the dollar outer on it. I need to have the dollar outer there anyways, so it's fine. But then you get this kind of stuff, which, kind of looks kind of cool. You can go play games and say, yeah, it's an array. And if the elements are, well, orderable, then the array is an orderable array, which means you can sort it.
Right.
If I have an array of unrelated things, I can't sort it. An array of orderable things, I can sort it. Wouldn't it be nice if the compiler would enforce that?
Right.
Yeah.
Python does something like that when it's got an array of its dynamic types, that it will sort them by the type and then by the value of the thing.
So how do you tell a function? You can tell it to that it accepts an array of elements, but how do you constrain that to be array of elements which are also orderable array?
So this is what it means. It's done by the compiler. Like Python, we're doing a runtime test. Are these elements of an orderable type? I'll use the orderable.
Right.
Here, I have a compiler support that says, wherever I use this array, somewhere in the world, I said, make me a new array of some kind of an element. But if I know something about that element, at that point, at the place where I make the new array, I can then call sort on it.
Sounds similar to conditional conformance in Swift.
Oh.
Yeah, and you also see type classes have some answers for this as well. But if you look at so Theodore, to answer your question, if you want, you could do it two ways. You could say only pass me an orderable array, because that's the mixin. And and if you get an orderable array, it is an array because it's mixed into it, right?
Yeah.
Or you could say, give me an array of orderable, in which case you also know it's an orderable array because it's an array of orderable and therefore automatically gets the mixin. So either one.
What if I make an ordered map and I want to make that orderable, I guess. It's not an array though. Do I still get to stick orderable on it?
Yeah, you could make an orderable map. In fact, I think we have sorted map, or something like that.
Sorted map.
What does it mean to be orderable? Because it depends on what the two types are. Some types are orderable with respect to each other and some aren't. The reals are all orderable with respect to the reals, but they're not orderable with respect to the complex.
No, but what is the type of element? Is the element type real or type complex?
That would be.
So you had a different question, which is, I have a pile of orderable things. I have an array that has complexes and it has doubles. Can I declare it an array of orderable and sort it? All the elements are orderable, but they're not orderable relative to each other. That's a good question.
But you somehow have to say.
Oh, the base type is. Why can't I do this, Cameron? Yeah, he's got a point. I'm curious, and I don't know. New array of whatever. I'm going to put in. I don't know the syntax. 1.2.
You can use the Java. Oh, yeah. I meant the square bracket stuff, but sure. Yeah. So the thing is, we would never compare an int to a float, to use the Java terms.
Weren't at this point.
Why is this type here? I'm gonna change it to be simpler here.
Weren't this type would be raised to an object, so you wouldn't know what are the elements.
No, we don't do that. That's Java.
No. I'm asking a different question. What do you mean you don't do this? If I throw this code into the XTC compiler,
we'll support that. That's fine.
And I call sort on it, right? And I go -1 and 2.3.
Right. Are these heterogeneous arrays?
Well, that's what I'm trying to sort out. They certainly can be, same as a Java has an array of object.
Or is 99 promoted to a float?
Right.
No. If you said it was a float array, then 99 would automatically be promoted to a float.
So what is this array then?
Doesn't orderable accept the type here?
Is it heterogeneous array of boxed objects?
Yes, it's all boxed. So it's ecstasy.
We don't have boxing. So Cliff boxes it for his translation, right? But ecstasy doesn't box.
Well, that's not fair. You have a mathematical description. Any real implementation would have to box.
Yes, that's fine.
Okay, so I claim you're
Does that just mean
actually
that it's always boxed?
yeah. It's
There's no
just no.
unboxed?
I do some hacks for uniformly nice arrays where I don't box, and that turns into all kinds of good performance gains. But as soon as crap like this shows up, it's all boxed. So
Right.
you might as well declare this as boxed. Let's just be honest with yourself. It's all boxed here. Oops, not integer. Float and integer. I'm using Java boxing names on purpose. So this is the mental model for the array that you should think of. All these things are, and the question for cameras, all these things are clearly boxed. Sorry, and all
And there
order,
is
all order.
and
That's
so
not
you cannot in ecstasy you cannot compare a float to an integer
right. But what is
or vice versa. So
what's the constraint that says
Yeah,
an array?
that's why I was asking about the element type.
Yeah.
Because if you do not have element type, then you don't know where to pick the orderable from.
so we do have element type. It is orderable.
Yeah, that's an interface.
So you don't treat it purely as a constraint, you treat it as a Java style interface that you don't fully erase at compile time, is
Right,
what you're
but
saying.
ordering is not a virtual call. So or
Okay.
So
Okay.
just like equality. So in this case, Cliff, just for the fun of it, change orderable to int or float.
But okay, where do you pick orderable comparison operator from for this particular array? If he didn't, I was actually more curious about the case when it was just orderable.
Right.
Both of these.
So, well, let me answer first with this one because I know the answer to this one off the top of my head. There is no interfloat class. So it runs at runtime in the interpreter. I don't know how Cliff will handle it in the compiler, but in the interpreter, it produces a fake class called interfloat, which sorts all of them based on how if they're the same type, it uses the comparison on int. But if they're not the same type, then it first it asks the types, which one comes first. So it would probably sort all floats first, I guess, and then all ints last.
It'll ask the types who comes first.
That is surprising behavior.
Yes.
So at least to me, I read that this should.
So how do you compare a color to a person? Or
I claim you should not, and you should throw, like, I'm surprised you don't throw an error and say you can't do that. But then, I can make an array of object, obviously, I just can't sort it. Right? Why am I allowed to sort this array?
Well, you wouldn't be allowed to sort an array of object because object's not orderable. Right.
Yeah, right. So I have an array of orderable. How do I sort it?
And
I feel like there needs to be a dynamic dispatch on orderable where it says, is A less than B? And then you have to go through all the same rules of like, can I do A less than B?
Oh, right.
Well, this gets to a question that I wanted to ask earlier, which is, do you have requirements for, like, for instance, you have this array and you extend it with incorporate orderable array into it, and that gives it the ability to sort the array, I guess. In Ruby land, if I recall correctly, it's been like a decade. You can stick an orderable mix-in type of thing onto an array, but or onto a type of your design, but you have to implement a compare method in that type. So it basically would fail if you called anything in the orderable interface or mix-in because it's going to be looking for your implementation of compare. And so then basically this array, which you're incorporating this thing into, has this compare function that's stuck into it. It's a requirement for that mix-in. And then that's what makes it work. And that gives it the flexibility with the mix-ins. So it's a pretty good solution, I think. And they do that for, they have a sort of general purpose collection thing that has all the functional collection things like map, filter, reduce. And it requires you to have like one function called like sequence or I can't remember what the function name is, but
Yeah, it's well,
so
it's
like
in ecstasy, it's an interface. It's called orderable. So and to be orderable, you implement that interface, but it's
right,
not
but that
but
seems
it's not a virtual call to do the compare. It's a
this
it's
wouldn't be a virtual call either because you'd have to implement it on the array class, on the thing that you're making orderable, and you're saying, okay, compare your elements, right?
Aaron,
Not a thing that if I recall,
no, I
it's not a thing
understand.
that's
Yeah,
implemented on the
so
thing
you can
that it's the content.
provide the ordering separate
Mm.
from the types
Hey, Cameron,
themselves.
how do I initialize an
I
array
think
in
so.
ecstasy? I'm not doing it the correct syntax. What's the right syntax?
Here, let me type it in for you. Um,
Anyway, my general sort of comment here, I guess, is that if you it's probably
Sorry.
worth spending a bit of time looking at how Ruby's done some of these things because I think it's generally considered a pretty well designed, if not very high performance language. And they have a lot of flexibility similar to what you're putting in here.
Oh, look at you with casting on those. Yeah, you don't have to get fancy. I want more, but I'll do that. That works good. Int colon 99, float colon 50. Now I have 4. Nums dot sort.
so orderable is itself a mixing, correct?
No, it's an interface.
It's an interface,
Huh.
but isn't it parameterized? Because if you parameterize it, then you are forced to compare two equal types, not int to string. So
Sorry, I
your
didn't follow
syntax
the question.
isn't orderable parameterized? For example, int what would require you only to compare to other ints, not with floats, not with something else.
No,
Like the
nothing like
comparable
that.
interface in Java, it's parameterized.
I don't understand why they did that in Java, but I'm sure it was something Josh needed for the compiler.
Your
So
float cast, Cameron, is not correct
It's because you're behind the mainline.
because I'm behind the what?
You're behind mainline. That's the thing that Gene added for Dima this week.
Can I just get rid of the word float?
I think you can say float 32 or float 64 instead. It just doesn't, it says float 64 probably. There was some missing functionality in the
Okay.
compiler.
So I get a runtime crash, a runtime exception, not a crash, a runtime exception saying there's no compare function for orderable.
That makes sense. Exactly.
So this is allowed to compile and fails at
But I
run.
thought the definition of orderable was that there was a compare function.
Well, the orderable is an interface. So I said, here's an interface, and the interface is like, I don't know how to compare two of me. So it's
which functions requires orderable to implement? Compare or some what orderable requires you to implement in order to count?
Cliff, do you mind if I share real quick?
No, let me turn on sharing. I'm going to finish writing that with the test case. Hang on, that's speed
Send
sharing.
request.
Yeah, that didn't help me because it popped up a window right as I was going to click permission yes.
Oh, sorry.
And then I got to click on the empty space and sort out, read the thing, and oh, what's it trying to? Oh, it's Cameron. Oh, okay. It's all good. It's just like
So this is orderable on the left.
you're going to have to increase the font a lot.
Yeah.
A lot.
I can decrease the size, which will increase the font. Oops, that's the wrong window. Let's try this one.
Yeah, same problem. Is always one of this, one of that. Da, 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 da.
How's that? How's that?
Yeah.
Okay, so is this big enough for people to read?
Yeah, readable.
Okay.
I can make this a little smaller. Let's do that. All right, so here's orderable. And basically, the if we take a look at comparable. Comparable is what this is comparable right here.
Mhm.
It's a funky interface that says, do you implement a function called equals? So if we were to look at, say, string,
Yeah,
actually
you're hitting
string,
hit on comparable, on compare, not equals for the
right.
sort. But yes,
So
same problem.
comparable compares two things for equality. Orderable
Yeah.
compares two things for
Find your compare in there.
for exactly. It's at the bottom. Compares two things for order. So ordered is less than, equal, or greater to. It's a enum. So
Oh,
this
so it's a three-way comparison operator,
it's a
basically.
three-way comparison,
Okay.
exactly. And it says I still know how to do equals, right? But I can also compare for order. And so the fact that these are both on the interface allows the compiler to flag a class that implements one but not the other. As you can imagine, that would probably not make sense since they're so this is what's called a funky interface because these are unimplemented functions on an interface. And then from that, we derive functionality like max of, which is the same as not less than, because it's based on whether you BRN the call or not. So UCS, universal call syntax, is that
Yeah,
it, Matt?
you see something
But
like
if you
that.
look at like not greater than in the code, you'll see something like take the remaining but not greater than the number of bytes, right? Things like that. And if you look for instead greater than
Fair.
is not greater than is min of, right?
Isn't not greater than just min?
Yes, in C it is. So that's what universal call syntax means, is you can take one of the parameters and move it to the left and dot it. You've probably seen this in other languages.
Yeah.
You have to be
So
a little
here-
careful about nans there, but sure.
Why is that?
Nans are going to be boxed. It's going to be about what a double does on a call that has the value the double is being
Yeah,
made.
I mean, nan is implemented by float 64 or whatever, so it does whatever the fuck it wants to. And it doesn't do what Java did. And by the way,
No, boxed doubles in Java of a nan are fine. You do, if you have a capital D double and you do a dot, blah, 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 it gets a nan in, fine, it does.
right, so you can say, for example, min of the two values. So yes, sorry, that was Derek, I guess, asking. That's your
The
C.
reason nans can be a problem is that if you write a sort algorithm that requires a orderable number, you would think that it would work, but it would run into infinite loop if you have an array with nans, because those nans would just consistently loop into comparing not equal to each other. So if your termination is that you do not have
In Java, yes, that is true. Or in any language that implements the less than operator as if it were the IEEE 754 definition for NAND comparison. But there's nothing in the IEEE 754 spec that says that the less than operator has to do that. So that's just people being stupid when they write a language.
Well, there's some amount of performance as opposed to stupid.
if you map to the
Athletic is
IEEE
finite.
hardware, which is
Don't
most
want to
of the
wish
current
away.
hardware. Yes.
So I have one question. What is a compile time here? Compile time, it's on.
Compile type is a type parameter at the function level.
Yeah.
So there's a hidden parameter here before this. There's a hidden parameter that says type of orderable compile type. So
Okay,
that
so
instead of writing that there, we use the Java syntax, even though Java erases it, we use the same syntax. So what I just typed is actually, we do it in the Java style.
And this aligns that the min-of has to have two of the same types in order to work.
Two of the compile type, because the compile type defines which function we will call here. So if you declare it as int, we will use int dot compare. And if you declare it as a superclass event, like, I don't know, say number, I don't think number has a compare, but if you said number dot compare, if they were compile time type of number instead, it would look for the function on number itself.
So this is a little, this is an effort to prevent the asymmetry on equals that happens in Java,
For
where the
example.
left-hand side gets to choose what equals means. And if you extend the right-hand side and not the left-hand side, the left-hand side is still choosing what equals means.
Right.
And the right-hand side is some unrelated subclass now and doesn't get checked.
So in Java, for example, you have sorted set, set, collection, object, and they all define equals differently. But if you have a sorted set and a set, and you say, does the set equals the sorted set? It'll use the sets definition. And if you reverse them, it'll use the sorted sets definition. In Ecstasy, if you had a set and a sorted set and you compared them, it would say, no, I can't. The compiler would reject it. It would say, you can't compile. You could cast the sorted set to a set, and then they would compare as sets. Or you could cast the set to a sorted set, and they would compare as sorted. Yeah, I'm
I saw
definitely
this in a Dr. Seuss book on tongue twisters.
I'm working on it. So anyway, that's the
Right.
That's
The
the
compiler enforces that everyone agrees on on how they shall be compared,
right.
despite the various class hierarchies that might come around.
So to circle
Cliff,
back,
if you write a type theory for babies tongue twister book, it will sell.
Oh
And you
my
can
goodness.
and you can see some of the operators here. So
I could do that.
so if I for example had you'll see all over the place less than oops.
Nuclear physics for babies by my niece, I guess, whatever granddaughter
So
has nuclear physics for babies.
in theory, this is a range, right? The compiler doesn't, I don't, I think the compiler recognizes this and skips making the range for it. But anywhere else that we would have this would be.
Yeah,
that would
the
be
Ecstasy
range.
compiler puts a range there, definitely.
Okay.
I get the ranges through from the disk format.
And
Yes.
that's definitely a range,
Yeah.
right? So that's a slice operation on a range. But the reason I can do a range is because it knows that this is orderable and it knows that this is orderable. So this is represented by the to operation that we just saw here. Sorry, that's to exclusive. So it's inclusive to exclusive. So that it doesn't, the compiler won't use that code for int or something because the compiler cheats and knows how to build the
I
appropriate.
get range objects.
Okay.
I'm translating to Java side. I cheat specifically and only for ranges events.
Well, they are the
I
most
get a
common.
range object of the full glory.
So anyway, so that's orderable. I don't know if there's anything
if
else.
we circle back to array of orderable, wouldn't be
Oh, do you want me to take a look at that?
I have. Let me share the doc here.
Sure.
There's not. Oops. How about this doc? There's not a whole lot more to be said we didn't already know. The compiler allows you to build this code because it is an array of orderable. But when he comes down to running it, his error is exception, no implementation compare on orderable. And it's because you need a compare implementation, which if he knew these were all ints or all floats, he would know what the ordering is. But given it's actually an orderable now, then there's no compare.
Yeah.
Orderable defines there should be one, but he doesn't implement one.
That's right. And the orderable array has things like min and max, so it has range.
Yeah.
So it has median. It has
you can do things on an orderable array.
Right.
Yeah,
exactly.
yeah. So if I was
it seems like you've got a very maximalist like library. You're putting in like every possible variant of the thing.
I think they've gone way overboard, but that's my taste. So I can't use FP literal as a number, Cameron. We should sort
Right,
that
because
out.
FP literal, like int literal, we talked about this the other day.
Yeah. I'm trying to figure out how to get an F. Oh, you said I could use float 32 here, maybe. I have
Try
another
float, do
variety.
float 64, because I think in the version you have float 32 is missing.
Okay. Oh, look at that. I got a crash. Yeah, oh, that is the crash that you debugged. Okay, yes, I'm off master by one. That is that crash.
Yep.
And I'm still getting, whoa, look at this. No conversion. Let me try int for int 64. See what happens
I
here.
think that's what Dima was, that's what Jim.
I am getting an internal compiler crash. It's probably similar one at Dima's. I'm using float 64 here. I'll show you what I did.
Mhm.
We're not seeing what you're seeing.
This.
Oh.
I changed orderable to number, and I put float 64 and int 64 to try and make them all stop, and it blew on me. So I'm going to try another hack.
I should have.
Yeah, I'm off camera. I'm just doing stupid hacks though. Let's see if I can get this to go. This went, gave me a different crash. Yeah, I think this is an actual crash, Cameron.
Yeah, so the code you just gave me that compiles fine here. Was it a question of running or compiling?
Then when I ran it, I crashed. So here's what I changed it to, which fixed the casting bug, which is known fixed. But now when I run it, I get this for a crash. Class cast exception, base binary FP float handle cannot be cast to, generic handle, and template.x const.call compare. This is the interpreter, obviously. So I claim in my workspace, this crashes. I didn't change this code, so this crash, as far as I know, is in the main. So we should hand that to Gene. I was trying to say number instead of orderable, because orderable is an interface like, okay, I don't implement. You're supposed to implement a compare. You failed, fine, because you're trying to pick one up by default by the body. I get it. But this version is a number, which should have a compare, and it should be compare an int with a float. And what do you do with an int with a float? I don't know. Actually, it's not insane.
So
I think your example
it doesn't blow up here. So, but let me actually print.
It doesn't blow up for you.
No.
Okay.
I think this is what got
Maybe
fixed.
Gene picked this one up too.
But can you extend it to know how to compare int and float something?
Well, there's an obvious comparison for ints and floats, which is
To
why I was trying to do
truncate it,
colors and
yes?
people.
To truncate and compare. To truncate
No,
the float.
you go to numbers class and you ask the number class, how do you compare ints and floats? A number does what number does. Which I claim you could convert everyone to maximal floats and maximal ints as maximal floats and compare.
So let me paste it in. That's the result.
Okay, so you now it does something. And in fact, it's sorting by number. Okay. All right, so that's been fixed. That's interesting. But then the answer is the question is answered by saying number knows how to compare ints and floats. Where if he has colors and persons, they don't have a common root other than object. And he does not know how to compare colors and persons.
Yeah, I'll check with I'll check internally on this one because I don't like what I'm seeing. But
so the numbers lost their integerness when they got sorted.
That's what I didn't like seeing. Yeah.
Oh, I see. I missed that. He cast them. Ooh, oh, then I could break you. Well, I could throw down max ints and you would just go to oh yeah, I could throw down two max ints that were slightly different. You would round them off to 57 bits as doubles and fail to compare properly. Yep.
Well, I don't have an answer for why I'm seeing what I'm seeing.
Yeah,
so.
yeah, right. But yes, I think that is an incorrect because my
I
my
would,
array elements are different than what they were a minute ago. You changed my array elements.
Is there a way for me to say I've got uh, colors and frequencies. Okay,
Mhm.
so I want to sort them,
Mhm.
and they are, colors are words and frequencies are numbers, but theoretically you could sort them. So um, I
Yeah, you
want
would just
can,
provide a comparison function. That's
Yeah,
the
you just
so
need
so the
do I
sort
have to add in
method.
both color and frequency or what?
No, you would just pass the function.
so at
Functions are
least
first
what
class.
Python does is it does priority search. So when it's comparing two things, it first gives the thing on the left. Yeah, I
Hmm.
think it first gives the thing on the left the chance to say, hey, can you compare yourself to your neighbor? And if that comes back and says, I'm not implemented, then it does a right compare and
Hmm.
hands it to the right side and says, hey, you're on the right side of a comparison. Can you compare yourselves? And if that fails, then it's like, sort them by type string.
Yeah, we will not do that.
So Cameron, when you say
Well, I like the
it will,
first two steps of first give the thing on the left the chance to compare it to the thing on the
No,
right, and then give the thing on the right the chance.
I'm kind of with Cameron on this one. That
it
the
will
compiler should enforce that everyone agrees before you start sorting that every left and every right knows how to sort each other and they're sorted. Therefore, they're using number and not int sort versus a float or float sort versus an int. It's numbers choice.
That flipping left and right could break a stable sort, right?
Uh-huh. Yeah.
Correct. Correct.
Not if you enforce it at compile time and say, look,
Yeah, yeah. But you said
this is
Python
a
did it at
thing
runtime.
that has floats. Either the thing on the left implements less than, or the thing on the right implements are less than.
Oh, I see what you're saying.
I posted an example of how to do that in Swift with the existential any. So you could use existential types, which basically allows you to have like a collection of generics, but generics are still allowed to change at runtime. So you can like put floats and integers together, and then you just have to teach the compiler how do you compare every single int with every single double with every single float. So all of the combinations. So you can customize it. I posted a very boilerplate version, but at least it should be easy to read. I just did all of the enumerations manually. On the left, you have the code when you implement the less than operator and the equals operator. The line 5 is the most interesting line because in line 5, it just says that the value is going to be of type any comparable, which means that that's basically like you're ordered, but it's still allowed to be
Sure.
different type. It can be an integer, it can be a float. And then if you scroll to the end,
I'm trying to get enough to see here.
line, yeah, you can see line 63 is where I instantiate this array. And I'm gonna be putting ints and doubles in there. And then they're gonna sort it and they're gonna print this out. And on the very far right hand side of your screen, you see the final result. So this is a very, very manual. I'm sure there is a more elegant way to write this, but at least
that
this one is very obvious to read. The
that would
boilerplate
require
version.
to enumerate all the types you are intend to
Yeah,
compare.
Yeah, he's got a case for every
So
possible
I want to
differ.
ask Cameron, when you say you can pass this compare function, so let's say the types are A to B, what would be the return types? You inside a closure, let's say you implement how to compare frequencies, and what was the other that Derek says persons or
You
numbers,
would, well, if you had a list
Colors and
of
frequencies.
colors and
if you had a list of colors and frequencies, you would write
Mhm.
a function that takes
Color or
two
frequency.
parameters. Each one is color or frequency, and
and
then
you would return what? So
Well, you
you would
return
return ordered. That's
less
oh,
than,
what, yeah,
greater, or equals.
exactly.
okay.
But
Okay.
inside that test, you'd ask an instance of, am I an instance of a color? Am I an instance of a frequency?
Yes.
And then if I had both instancy and frequency, you had some decision to make. Here, Matt made a
Mhm.
decision that when he compares the left as an int, this is line 20, with the right as a double, he cast the int to a double,
Yeah, and if we implemented
which
compare
truncates the low
on
order
the
bits of the
number
int as
type
part of the
itself,
compare.
this is exactly what we do on this is what number should do.
Mhm.
Right. What I'm pointing out is this truncates the low order bits of the int. If it's a 64-bit value, it
And-
doesn't fit in a double. The lower bits are truncated and compared that way.
And when you call
Correct.
sort,
Right.
when you define how to compare numbers and frequencies, and when you call sort on that, what would be the return type? Array of comparable. It will lose type information that way.
No. It should be array of
No.
comparable down here. You're talking about the Swift, or you're talking about Cameron's version?
The Cameron's version.
Let's go
No,
to
it's the
Cameron's.
same type as goes in.
Yeah. This num's still an array of numbers or an array of orderable or whatever it's going to be, array of int float. That didn't change. What I'm with Cameron on is 99.0 is incorrect.
Mhm.
I've-
Because
I've
it's
already
converted to
reported it.
double to
Because I
float.
got it converted in place. My elements got
Yes.
crashed.
And so,
Yeah.
but that would return you array of floats.
No,
Is
it
the sort
returned me an array of number.
Exactly.
Array of number. Okay, that's
Whatever, right. It didn't even change the array. I mean, it updated, it mutated in place. So the base object type never changed. The base object never changed. The elements
And
changed.
I guess in the thing we were looking at before, it's like, yeah, the int double comparison was potentially wrong, but anyway, it doesn't, like, it's just an example, and that's there's place to put that logic, so you could actually have the correct logic there, right? It's not like it's not like the concept is invalid.
No,
Like I'm
right.
talking
The
about
sort here is
the
missing
compiler
function. What Matt
explorer we
was
were looking
doing.
at before.
Matt was adding the function inside of here. There's a lambda missing
Right.
that says X arrow, and it asks the instance of X or float, and I guess it's an X and a Y.
X and Y, exactly.
And then he masks the questions, and then he has to make a decision, ints versus float. So you can imagine taking the floats, subclassing the floats to add a unit and doing unit math. And a replacement here like this, Cameron, where I was doing unit math would be strictly incorrect. I lost my units. Right, so I make a class unit extends float. Inside it has some, enum of meters and kilograms and what's another base unit type, time, seconds, and I have an enum of units, and somewhere in here I have an array of units. And someone said, "Oh, make a new unit array," and it's come spacing here. Meters a second, and also it's a float, so there's the float has the built-in number like 2.3, and I'm moving meters per second, and then I come along and I sort. I better not lose my meters per second.
Right. Yep.
I claim that the Java translation of this will not be pretty, but I guess it wouldn't be any worse than what I would do if I was to handwrite it.
Right. It's going to be ugly.
It's going to be ugly no matter what. Yeah, it's definitely going to be boxed. Definitely have enum bits splattered about it as well as the original value. But, fine.
okay. Cool.
Yeah, right. Yeah, kind of interesting. You can imagine
And Matt,
extending.
we do have the existential types as well, so that same approach is present.
Yeah. We beat this horse to death.
Mhm.
How I spent my summer vacation was this step.
Yeah, I'll paste in the sort code. It's not too ugly.
Not too ugly.
This is on the list.
Fine.
I'll paste it in. Let me find an empty box.
Here is a Swift min max from Matt.
There it is.
While you're pasting, I'm going to flip to min max here and see what comes around. I got your same compiler explorer link, Matt.
Did that break?
Oh, it's because you're just doing.
Sorry, wrong link. Try again.
Reload. Try again. Oh, new link.
Wrong link. Yeah. I don't know why. Copy paste. So there is basically, as moment you have comparable, you can implement min and max, and a good test if you can implement min and max for a collection. So for example, if you have collection of numbers, like on line 337, and then you call min of this, and you want 3 minimum numbers. Note, this doesn't require you to sort the entire collection, right?
Yeah.
Because you are only asking for the top k or min k elements.
Yeah.
And there is an efficient algorithm for this complexity in line 351. This
Yeah.
is definitely smaller than sorting the entire sequence and then picking top 3 or bottom 3 elements.
Yeah.
So this is a good test if you can efficiently implement this. The moment you have something like comparable, you should be able to do that for collections and test the conditional conformance. Does it buy you something, so to speak? And that's one of the examples where it buys you something.
Wow.
I actually kind of like this code base because the comments are pretty good, I would say.
There's some
I
pretty
always,
massive,
yeah,
Yeah.
I like the comments.
pretty massive, but right. That's good. And the examples are nice.
Yeah, it's minimalistic and readable, and I like that I can quickly look at this in a hurry and I don't have to, make up my own examples. So someone has definitely spent some time on this.
Yeah, yeah. Is this the Swift stuff? Yeah. Looks good. Fine. All right. We get another. Oh, here's your sort. And this is the optional
Yep,
function.
exactly.
And this is your, I think you guys got the wrong concept for in place versus mutable, but that's the different problem. And then there's quick sort or not. You're picking
Right.
left or right. Yeah.
Whatever. I mean, it's a bubble sorts faster
Yeah.
for most arrays
Because mostly they're small. Yeah.
because they're mostly empty. Exactly.
So for people who don't read this, this says go get element orderable, and if there isn't one, then you throw. But if there is one, you've just assigned the variable order with whatever the element's concept of how it orders things.
Exactly. So the type knows if it's ordered or not, and if it is ordered, it returns for this method, it returns a Boolean that says, yes, I'm ordered, and here is my function that does the ordering.
For ordering. Yeah. Yeah.
And that's what allows us to order the type int or float or string or color, right? Because the type itself only exists in the linker or post linker stage, right? Because the union isn't something that you write as a class. It only exists.
Well, but what does int or float use for what it means by being ordered then?
Well, that's what I was saying earlier. It first, if the types are the same, it uses that types definition of ordering. Otherwise, it orders it based on the type itself. So it'll put all the types that are, if it's string or color, it'll put all the strings together and sort them, and all the colors together and sort them.
But how does it order strings from colors? What comes first, the string or the color?
So type dot compare will answer that question.
And what does type dot compare do?
I don't know. I don't forget. I can't. I just can't remember all the stuff off the top of my head. So
What came first, the chicken or the egg? I'd rather take a type error at that point, saying, "You got to tell me what it means to sort chickens and eggs."
Or tell you that you don't care. So there's a case that I've run into before where I have like a B tree full of JSON objects. And I don't really care what order they sort as long as they sort in some kind of stable ordering.
What was the purpose of the sort then? You can binary search it?
Yeah, there were indexes that I could find for things and search relatively quickly based on that. Same if I had just put them in a list of sorted things that I knew they were going to end up in the same order of two different people.
Use that same comparison function to do binary search.
Right. But the type turns out to be this nasty type because it's like int or string or true or false or none or
nans. Nans and infinites showed up special later in life in JSON.
And the answer is I didn't actually care how they sorted it as long as there was some sort of stable sort that my
Yeah.
two nodes that got the same set of keys would end up with them in the same order.
This
Yeah,
is
because
the same as Cameron's doing here. Yes, there is a sort order. It's well defined. What the definition is? Keep digging, keep digging, keep digging. Oh, I don't care. Interesting.
I find
Right.
it
And we ended
surprising.
up doing something terrible, like serialize them all into strings and then sort based on that string. That
There's
was
your
almost
problem.
entirely wasted because it only cared about the
No.
first four
And
characters,
how
but a
many
JSON
CPU
stringified
man
the entire thing.
hours were, dollar
Um,
bills of heat were wasted
Yeah.
on
and it was a
that
very
one?
dumb solution, but it was just because like I wanted to stick into this data structure that cared about
Yeah,
ordering a
right,
thing that just needed
right.
an order. There's something nice to be able to say, hey, compiler, just brute force this thing till you get an order. And if the things know how to sort themselves, great, use that. And if they don't, fall back to the types. And even if you're doing something stupid like putting all the floats first and all the ints second, I don't care. Just,
Yeah, right.
hey, compiler, brute force me into some kind of ordering for this that
Wow.
is at least stable.
So you simply need to add a sufficiently advanced dependently typed system so you can add an SMT solver that's going to come up with the optimal sorting function.
This is like
I think Levo should do this over the weekend.
all interesting compiler discussions end at dependent types and then they're over.
I think I think we could build a crypto coin based on this because I think we
Yes.
definitely just invented proof of work, or at least proof of effort.
Yes.
Right. I mean, so that's the way I've seen this seen solved in earlier systems was if you're in something like Java that has a hash code, you just say put all the things into the data structure by hash code and sort them by hash code, and the hash codes are just a register size
So you know
number.
what?
So
I think we're
Dude,
mixing two
dude.
concepts here. There's the concept of you want something in order, and typically people have an idea that that's some sort of meaningful order. And then maybe you have like a forced consistent order as a separate concept where, yeah, it's going to be like a weird order. And that's where we look at the types, we look at hashes, we look at whatever, and we just make some order. That is a different concept than ordered, I would say. And you should have a different mixin for that.
You'll have collisions on the hash. Right.
Oh.
That seems like a bad choice.
I'm just saying that, you have some, I'm not trying to implement this for you.
Yes.
It's an exercise for the viewer, but
Yes.
I'm just saying that these are separate concepts,
Yeah.
and then it sort of resolves some of these like questions that I think that Aaron was asking.
something similar happened in Unicode. Do I care whether Russian symbols or English symbols are first alphabetically? No. Do I want them to have some order so I can sort strings? Yes.
Only if you're going to do lookups later.
Yeah, and
more lookups than
if you have a couple extra 100 years, you should write a Unicode normalizer.
We are definitely heading into the weeds here. And I think we can call done. And I can go get a lunch and figure out what I'm doing the rest of my day.
Sounds reasonable.
Yes, we've had rain. It's wet. It means I can run a campfire. I have two
That
burn
feels
piles.
backwards to me. Don't you normally want to burn dry wood?
I want the campfire to not get out of control because my campfire is going to be 10 feet by 20 feet by 10 feet high. I am burning the...
At some point, camp becomes Bon.
Yes. I am burning the burnables around my property that keep it fire safe. And I chopped them down, cut them from the start of the year, and they've been drying all summer. But the piles are large. There's a lot of it. It hasn't been a while since it's been done around here. We have a lot of wood to burn. This would be like a full-scale chipper for all afternoon to chip it and end up with dump truck load of debris of chips or burn it. So,
or burn it.
But you can burn it when it's wet and humid and cool and not windy and fine.
As long as there's no Burning Man.
Yeah, that's right.
Californians do like to not set their
hobby.
state on fire.
It sets itself on fire plenty often enough. Falls into the ocean, shakes itself up, mudslides, earthquakes.
Did you get the tsunami warning last week?
Tsunamis, yeah. I got the tsunami warning, but I'm, 2,700 feet above sea level. So if tsunami hits me, I think everybody's in trouble. I don't think wherever you're at, if you get a tsunami hitting me, you're in trouble too. This dinosaur killer time. All right. Till next week. Bye-bye.
Uh,
Right.